So now we're revisiting example 6 through the tic-tac-toe method. So remember that this is the function that when we took the antiderivative, we had to do integration by parts twice. Watching the stand and deliver video, Jaime Escalante did it in a matter of seconds using, he just said tic-tac-toe. So here's what you do. You still choose using lipid what part's going to be your u and what part's going to be your dv. So our u part, of course, is our x squared. And our dv is going to be our sine x dx. Okay, so now what I'm going to do in this first column here is I'm going to continue to take the derivative all the way down to 0. So we have 2x, take its derivative, we get 2, keep going until you get 0. And that's when you know you're supposed to stop. Okay, in the next column, you're going to take the antiderivative until you reach this last row here. So the antiderivative of sine, negative cosine. Antiderivative of negative cosine is negative sine. Antiderivative of negative sine is positive cosine. For the last column here, you're going to do a little sign change here, starting with a positive. So the first one's a positive. So it essentially means that you're going to multiply it by a positive 1. Then you're going to multiply by negative 1 and then a positive 1. All right, so now as Jaime Escalante said back in that video, back in 1982, that's actually Edward James Olmos, I think. Anyway, Jaime Escalante. So we're going to connect the dots like this. We're going to use our, remember it's supposed to be a u and times a v. So it's x squared times a negative cosine times a positive 1. And then go to the next column here, or the next row, 2x times a negative sine x times a negative. These two negatives are going to cancel each other out. Then we do 2 times cosine times a positive 1, and here's our final answer. Don't forget your plus c. Notice that that is exactly the same answer that we got. So this tic-tac-toe method, it actually has a name. It's not called the tic-tac-toe method. It's called tabular method, and it works best when you have a polynomial function, like x to some sort of power, multiplied times a transcendental function. It happens when you have to use integration by parts multiple times. And one of these derivatives, and that's the polynomial one, should go down to 0. So the technique that you use is you differentiate your u function until you get down to 0, and that's as big as your tic-tac-toe table is going to be. And then you're going to integrate this next column until you reach that 0 row. And then over here, you want to alternate your signs beginning with positive. Here, let's put together an example. We're doing this whole tic-tac-toe tabular method from start to finish. And we'll do one maybe slightly more complicated, one that you would have to use integration by parts more than just 2 times. Okay, so let's say that we're going to find the antiderivative of 5x to the, third times cosine x this time. Okay, so I know that if I were going to do integration by parts on this one, taking the derivative of this is going to make this an x squared, but it's still going to be multiplied times, like the antiderivative of this would be sine, and so I would have to use integration by parts. This is a really good candidate for this tabular method, right? So we have polynomial function that we're multiplying times a trig function here. So this polynomial function, this is going to be our u in lipid, and then the cosine x dx is going to be our dv. So our u should be equal to 5x cubed, and then our dv is going to be equal to cosine x dx. Let me just kind of draw a little line here. All right, so now going downwards here for the u, of course, we take the derivative. So our du is going to be equal to 15x squared. And now you just keep going until you reach 0. I'm going to have 30x. Take the derivative again, I'll have 30. Take the derivative again, I get 0. So now we know when we're supposed to stop. We have 4 rows here. We're going to have to take 4 antiderivatives of cosine x. So taking the antiderivative is going to give us v equals sine x. Take its antiderivative again, we get negative cosine x. Take its antiderivative again, and we get negative sine x. One more time, we get positive cosine x. All right, and then the last column here is a sign change, starting with plus, minus, plus, minus. Just alternate them. All right, So now, here, actually, let me do this with the highlighter. Yes. We're going to start with the u. Remember that integration by parts is a uv. So you're going to go with your u to your v, and it is 5x to the third times sine x times positive 1, essentially, just meaning that you don't change your sign. So we have 5x cubed times sine x, right? And then the next one is going to be the 15x x squared multiplied times negative cosine times negative 1. So these negatives are going to cancel out. So I'm back to being a positive term again. So plus 15x squared times cosine x, right? And then we're ready for our next one. So it's going to be 30x times negative sine times a positive. That just means we don't change the sign, so it's going to be a negative this time. So negative 30x sine x. And then it looks like we have one more 30 times cosine x times negative. That negative means that we're going to change the sign. Negative 30 cosine x, and then don't forget your plus c. So a couple things here. You could always check this gargantuan thing by taking the derivative and confirming that you get this guy. And then also just look at it term by term. Look at this and compare it to this one, compare this one to this one, compare this one to this one. You'll probably notice something very, very interesting about each of those terms in a sequence.